Hello and welcome. Today you will be watching a professional development video about cognitive theory of multimedia learning, a few different principles of learning, and how you can apply this to your teaching practice. I hope that you are able to learn something and apply it later on. Let's go ahead and get started. The first step is going over the theory of cognitive learning. Cognitive learning is all about human cognition. This includes your long-term memory, your working memory, and your schema. These three are the building blocks or the architecture of our memory system. Each one of these three do something different. The long-term memory is any information that you can pull out of your brain and remember after a longer period of time that is there. The long-term memory does not have any known capacity that we know of as of right now, so you may be able to learn multiple things without it running out of space. This is very different compared to the working memory. The working memory only holds about 20 seconds of information, or only roughly around 7 elements, give or take 2, and therefore you lose this information. So for example, if I put this number up here and you are not actively rehearsing it, within 20 seconds you're going to forget what it says. This did not make it into your long-term memory. I bet tomorrow if I asked you to recite this number again, you wouldn't be able to. Whereas most of us know the answer to this. This is an example of long-term memory. You're able to pull it out and tell me what this is. You all know the example of this, or for example, what this animal is. That's because we've seen it so many times and you've pulled that knowledge out of your brain so many times that you can remember it. Now, the difference between those and schema is that schema helps organize all of those things. Whenever I think of schema, especially when trying to teach my third graders, I think of this. This is that episode of SpongeBob where all of his memory is falling apart and he can't remember anything at all. Now, the schema is the one that helps organize those files in your brain so that when you're ready for that information to be pulled back, it's pulled out of your brain and you can remember it. So for example, if asked what this is, your brain goes, oh, animal, oh, cat, oh, tiger. And then you can tell me this is a tiger. And obviously I work with third graders, so it's a little bit lower, and you guys do too, and that's okay. But that is kind of the inner workings of the memory and what makes up the cognitive load theory. The cognitive load theory, other than just the working of your memory system, has 3 different types of cognitive loads. We're going to go over those 3 types now and how you can apply it in your classroom teaching. The first cognitive load is going to be intrinsic load. This is going to be where you process the actual inner working materials themselves. So for example, if I put this problem up here, you're going to be actively processing what this means and trying to solve it in your head. That is that intrinsic information. Sometimes you have to know different steps before you get to knowing this. That is all your active processing skills working in the moment. That is what intrinsic information is. Now, there are 2 different types that I'm going to go over as well. The second type is going to be germane cognitive load. This is a little bit different. This is going to be the actual inner workings of your schema and the processing that is happening. So, for example, you have to know what this is, and you must be able to understand this first. So if you don't understand the repeated addition eventually leads to your multiplication problem, your inner workings of your schema are going to be messed up. Now, if I tell you that repeated addition is first, and then I go back and teach you multiplication, I can say, hey, remember when we learned about repeated addition? You're pulling that information out of your schema and adding and processing new information. This is that germane cognitive load working. The third type of load is your extraneous cognitive load. This is any information that is added to the learning process that is not needed. This is not needed for learning. You don't need it to process any information or to learn any new skills. So for example, instead of just that simple multiplication problem, if I gave you this, there's a lot of extra stuff going on here. I don't really know what's going on. What am I supposed to be looking at? What is my question? What is my answer? It's a lot harder to tell. Now, if you eliminate this extraneous cognitive load, your load capacity goes down, making it easier for students and yourself to learn. So you want to make sure that you are minimizing extraneous cognitive load while managing germane cognitive load, and then maximizing intrinsic cognitive load, making sure that you are really maximizing that active capacity so that our students and us, we learn more that way. And those are the 3 different types of cognitive load. The next theory we're going to discuss today is the cognitive theory of multimedia learning. This is the theory that goes along with words and pictures and how they are aligned together in learning. This theory does have 3 different assumptions, which we're going to cover now. The first assumption is what is called the dual channel assumption. This is assuming that your ears process one channel, the same time your eyes process another channel. And since this theory is all about how words and pictures process together, this theory is super important. So, for example, we all see this picture of an elephant here. You're processing it with your eyes. At the same time, I'm describing it with my mouth. So you hear the words, and it's processing through your ears the words that I'm saying. This elephant is gray. It has a round shape to it. The same time that your eyes are processing this information. Therefore, you're maximizing your learning experience because you have both channels of opportunity. The second assumption is the limited capacity assumption. This states that you only have so much capacity, in which case you can process information through each channel at a given time. So for example, if I give you this slide of information and I start talking to you about my day today, giving you what we're going to be doing the rest of the class after you read this slide and after you do all these directions, and I'm saying, okay, get out your pencil, get out your books, start writing it down, let's get going. You're trying to process what I'm saying with your ears, but then trying to read this slide at the same time with your eyes. You are struggling because cognitively you are overloading those 2 systems. Therefore, this is what the limited capacity assumption states, is that we can only handle so much information in each channel at a given time. The third assumption is the active processing assumption. This states that we are not just passive learners in education, where we are not just regurgitating information. We actually have to be active in learning the information. So, for example, this is a fun fact that my students love. Did you know that this horned lizard actually shoots blood out of its eyeballs? I know, crazy, but they do. And since we are actively processing this information, especially if you didn't know it, you're probably thinking, well, why does it do that? And then your schema jumps in and say, well, probably to protect it from predators. And you are actively processing this information, and therefore you're going to learn it and remember it for later because you processed it and you made a mark in your brain on your memory, and therefore can remember it for later. And that is what the 3 assumptions are of the cognitive theory of multimedia learning. There are multiple different principles that can help with learning and help you as a teacher make sure that your students are learning even more efficiently. For example, one of my favorite principles is the signaling principle. The signaling principle really helps to signal your learners' attention to what you want them to be learning. This helps because it doesn't overload their working memory. It gets rid of the extrinsic cognitive load, getting rid of anything that they might not need because you're pointing their attention in a certain object or at a certain point of material. And then it helps for your working memory to be able to process it because it's going to help them start at a point and then continue on to where you want them to. That way they're jumping around in their cognition levels and they don't have to remember different pieces of information before you move on. So for example, what this might look like in the classroom is if you give your students this passage and you say, read this part of the passage, and you don't use any signaling, it's a lot harder for their brain to then process all of this information and then remember the material. Whereas if I were to use signaling and add the signaling to this information and say, read this passage, now it's a lot easier for your students to pinpoint what you want them to read, and then they're able to remember this information, whereas they don't need to focus on the extraneous cognitive load of that extra information that they might not need later. The second principle I would like to talk about today is the spatial contiguity principle. This is where you have the words and pictures closer together compared to as farther apart. So something like this compared to this. And this is helpful because your working memory, as stated earlier, can only hold so much information. It has a severe limited capacity. So if you're completely toggling back and forth between the pictures and the words and the pictures and the words, it's a lot harder for your memory to remember and understand this material. So if you place it together like this for your students, they have to then not scan back and forth between the two, but then they are able to more easily organize and integrate that information into their brain, which helps store it for longer term memory. Plus, it gets rid of that processing and gets rid of any unknown information that they might need, so therefore reducing that cognitive load, which is more helpful for learning. The third principle is the temporal contiguity principle. This is where you want to make sure that you are not overloading your senses and your working memory at the same time. So what I mean by that is you want to make sure that you are giving a picture and the words at the same time. So instead of me showing you this picture and then waiting to explain it once the picture is gone, by doing it that way, you would have to remember what's all in the picture and then remember what I'm saying and then put the two pieces together. Because we have that limited capacity assumption, we can only hold on to that information for so long. And since we have the dual channel assumption, you can process with your eyes the same time you're processing with your ears. So it makes more sense and better for learning if you give both the picture and the words at the same time. So, for example, if I were to say flamingos were actually not born pink, and I give you this picture and I say that at the same time, you can process it. Versus if I give you this picture, took it away, and said, did you know flamingos were not born pink? Well, then you kind of have to remember what the flamingo looked like, and it's a lot harder to process that information. So making sure that you do it this way is better for your learners and better for you. The last thing I want to talk about today is refutation text. This is where you're going to give a common misconception, something that students are often mistaken about, and then partner it with the correct factual information. So something like this. In science, most students think that observing is only using your eyes, whereas it is actually utilizing all 5 of your senses. So by partnering it like this, you can then up front address that misconception. By addressing it, you are bringing awareness to it. And according to the conceptual change model, this is how you can change their thinking. So you want to make sure that they're aware of that misconception and then give them that factual information. By doing this, they're going to want to relearn and process that new information, whereas if you weren't to do it like this, they, 1, probably wouldn't look the information up on their own, 2, probably wouldn't believe anything else that you said, and 3, it's a lot harder for them to then learn that information and want to learn that information because you aren't partnering the two things together. By doing it this way, the conceptual change model says that you're in better luck for your students to actually learn, process, and want to learn the information that is the correct information instead of the information that they may think is correct. Alright, thank you so much for watching, and I hope that you will be able to apply some of these things in your teaching practice. I hope that going through the cognitive theory model, the cognitive theory of multimedia learning, as well as the principles, assumptions, and the refutation text gives you a few more ideas on how to help those students learn more in your class and how to better prepare your time. So many teachers waste so much time doing so much extra things that is not helping the students learn. By doing these things, you can both help them learn and help you at the same time. Thank you and have a great night.